All right, so this angle here, if we look at it this way, okay, it would be about negative 100 degrees. If I look at it this way, it would be positive 260. So they essentially name the same angle. All right, so you got your vertex is basically where the two rays meet. I think we're pretty good with that. Initial side, terminal side, measure the angle. Okay. Now this is on there. This is kind of where that first picture is. Okay. That first blank should be standard position. Okay. Okay. An angle in a rectangular coordinate system is said to be in standard position if its vertex is at the origin and its initial side corresponds with the positive x-axis. All right, now this is kind of what we understand to be what's going on. For most of our angles, we're going to kind of assume that the initial side is right there on the x-axis, okay? Theta is in standard position. Theta is typically the Greek letter used for angles. For this one here, theta is a negative angle, and it lies in quadrant 2. Okay, so it has to be, in this case, I don't know, about what, 230 degrees negative? Okay, for that one. All right, this is something that's typically new. It's what is a quadrantal angle? Basically, any angle that's terminal side lies on one of the axes. So it would be like 90, 180, 270, 360. Okay, and then also the negatives. So negative 0, you could say 0, negative 90, negative 180. Okay, those are all what we say quadrantal angles. So that's typically something you haven't heard of. So in that case there, that angle would be 270 degrees. For that. All right, for this case here, it says draw an angle with the given measure in standard position. That means the initial side's the x-axis. Then determine in which quadrant the terminal side lies. All right, draw those three. See what you come up with. Do attendance. Present. All right, now the first two you should be fine on. The third one, just stop and think about it for a second. 210. Now again, these are all standard, which is important. It tells you where to start. That's going to end up in quadrant 3. So you go 180 degrees, 30 degrees past that. Negative 45. Okay, you start at the x-axis. It's going to be in quadrant 4. You're going 45 degrees off the x-axis. 510. You got to do a complete revolution, and then you still got to go 150 degrees more. So the terminal side is in quadrant 2. So you're going to take 510. Whoops. 510 minus 3. Oh, this is not listening. 510 minus 360. So 150 degrees for that. Those 510 and 150 degrees are called coterminal angles. Okay. It just means their terminal sides are at the same spot. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. So technically, how many coterminal angles can I have with 150? infinite. You just keep adding 360 degrees, okay? So just keep adding, it's all going to be coterminal to that same angle. All right, we'll come and revisit that here in a few minutes, but that's coterminal. All right, we got something called decimal degrees versus degrees, minutes, and seconds. You are more comfortable with decimal degrees, but there's also something called degrees, minutes, seconds, which is used a lot in like surveying. So we use degrees, minutes, and seconds, which is a program up in Akron. We usually have a guy come in, but they couldn't do it last year. It talks about their surveying program. All right, before we get to this is the relationship. 1 degree is 60 minutes. Okay, just like 1 hour is 60 minutes, 1 degree is 60 minutes. 1 minute is 60 seconds. That's the notation for minutes and seconds, 1 little mark versus 2. So using that fact, 1 degree is how many seconds? Well, I got it down there on your paper, but make sure that makes sense. 1 degree is how many seconds? 3,600. Okay. Now, think about that. Okay. So you got each degree, we cut that into 60 minutes. And then you cut each minute into 60 seconds. So 60 times 60 gives you that 3,600. So every degree I can cut into 3,600. That's not degrees, that should be seconds. Seconds. All right, now how do I convert 54.38 to degrees, minutes, and seconds? Well, how many, you got 54 degrees. That's how many whole degrees you are. We got 0.38 of a degree. Well, how many minutes are in that degree? How many minutes? All you got to do is take 0.38 times 60. Okay, go ahead and do that. And what's that give us? So you take 0.38 times 60. Lane, let me know what you get there.
22.8.
22.8. So that means, let's make sure this makes sense. Now I got 54 degrees and I got 22.8 minutes. Okay. To figure out how many seconds there are, you take 0.8 times 60. So I take 0.8 times 60, which is 48. So which means I got 54 degrees, 22 minutes, and 48 seconds. Now, it doesn't always work out to be a whole number every time. Okay, and this one it did, but if you might have to round off. Sometimes that happens. All right, but 54 degrees, 22 minutes, 48 seconds. All right, let's go the other direction. Convert 112 degrees, 15 minutes, and 42 seconds into like a decimal. Start with the seconds. You got 42 seconds. That is a fractional part of a minute. It is 42 out of 60. So divide that by 60. So take 42 divided by 60. 0.7. So that means I have 112 degrees and 15.7 minutes. Okay, now take 15.7, what do we do with that? Okay, that's the fractional part of a degree I got. Josh, what should I do with that?
Divided by 60.
Divide that by 60. So take 15.7 divided by 60. And that gives me 15.7 divided by 60. 0.261. 6 repeating, depending on what you're asked to round it to. So 112, let's just do 0.26 degrees. Okay, 0.26 degrees. All right, now this next one, 35 degrees, 24 minutes, and 16 seconds. Don't round off till the very end. So you're going to get a decimal. You want to keep that. See if you can keep that until the very end. All right, 35 degrees, 24 minutes, 16 seconds. Now, when I do 16 divided by 60, okay, this is that case. I don't want to round that off. So 16 divided by 60, 0.26 repeating. So just hit plus 24. So that would be the minutes, 24.6 repeating, and then divide that by 60, divided by 60. 0.404 repeating. So it's going to be 35.404 technically repeating, or depending on what you're rounding to, 35.404, either way. Now, your calculator, if you find the right buttons, can basically do about everything for you. Find where it says apps, look above apps. What's it say in blue? Or at least mine says in blue. It says angle. You see where it says angle? That's our angle menu. So hit second angle. Whoops, not second sign. Second angle. Okay. That's the degree symbol. That's the minute symbol. Number 3, that stands for radians. So be careful there. And we're going to get to that later. And 4 is DMS, which means degrees, minutes, seconds. So what was that first one we did? We did the 54.38. So if you do this, if you do 54.38, and I hit second angle in degrees, minutes, seconds, and then hit enter, it'll give me 54 degrees, 22 minutes, 48 seconds. Okay, so spit out your answer for me. If I do that last one, okay, now here's how you have to do this. 35 degrees, so hit 35, second angle, degrees. 24, second angle, minutes. Now, seconds, I have absolutely no idea why, but the seconds are where the plus sign is in green. Okay, that's where they're at. They're not under the angle menu, and I cannot tell you why. I should probably Google that at some point. And you got to hit alpha and hit the plus sign, and then when you hit enter, you get the same thing, 35.404 repeating. Okay. So yes, your calculator will do this, a lot of this for you. Those 5, 6, and 7. Let's see here. That's rectangular to polar. I don't think I've ever used those. I don't even think. Don't worry about those. All right, flip it over on the back. Now this is kind of a little prelude there, so you don't actually need to get this down, but pay attention. So you got degrees, which we can measure with decimals or degrees, minutes, seconds. But kind of like linear measurement in science, you got meters and inches, or you got centimeters and inches. Which one is like in the scientific community, like typically used? Centimeters and meters, right? Okay. In math, you got degrees and you got radians. Typically, we are going to use radians, and this is what you are not as familiar with. It's just the same thing. 2 different ways to measure the same thing. Degrees is arbitrary, though. How many degrees are in a circle? 360. Why are there 360 degrees in a circle? Because somebody said, hey, let's use 360. And somebody else said, okay, let's do it. And so we chose 360. Radians is based upon a mathematical foundation. This is my angle. If you measure this arc, and if that arc has the same measurement as the radius, that angle is 1 radian. So theta is equal to 1 radian. So it has a mathematical foundation behind it. Okay, it's not just an arbitrary choice. And so this just describes what we just said. A central angle of a circle has a measure of 1 radian. 1 radian. If it intercepts an arc with the same length as the radius, just what we talked about here. Okay, so that angle is 1 radian. How many radians are in 360 degrees? Does anybody remember? Eric.
Was it 2 pi?
It is 2 pi. Now why? Why? Okay? Now think about this. So you got 360 degrees. What is, to figure out the number of radians, you got to take the arc length divided by the radius. Well, what is the arc length of a circle? The arc length of a full circle is the circumference. Well, how do you measure the circumference of a circle? What is the formula? 2 pi r. So the circumference is 2 pi r. So to figure out the angle equals the arc divided by the radius. Well, radius. So the arc is 2 pi r. The radius is r, so what cancels? Radiuses. So that's how 360 degrees is equal to 2 pi radians. So you got into that last year, maybe not as much as normal, but 360 degrees is the same as 2 pi radians. How many degrees are in 1 radian? Okay, to the nearest 10. How many degrees are in 1 radian? Okay. So 360 degrees equals 2 pi radians. To find the number of degrees in 1 radian, divide this by 2 pi. Divide that by 2 pi. Okay? And just divide that. All right, nearest 10th. Clayton, what do you got?
0.01.
You got what?
I don't think I got the right answer.
Okay, and maybe this, you got to be careful here, and I'm not sure if this is the case, but when you take 360 divided by, if I'm dividing it by 2 pi, with my calculator, I gotta put it in parentheses. If you got the ones where it makes a fraction, I think you're okay with it. But if I do that, I get 57.3. So 57.3 degrees equals 1 radian, approximately. So that right there, that's about 57.3. It looks logical for that one. All right, now converting between degrees and radians. Okay, that's going to be a big thing here. You're going to be more familiar with degrees, so a lot of times you kind of mentally use degrees, but your answer needs to be written in radians. The better you can become with radians, the easier this whole chapter will be. Okay, kind of force yourself to use radians when they ask you to. All right, to convert radians to degrees, you multiply by 180 over pi. Now, you don't need to write radians. Most people are just going to do this. Hold on. 180 over pi. Okay, to convert degrees to radians, multiply by pi over 180. Okay, for that. Now, I got 210, 300, 450. The way your paper is, you probably want to put that on the right-hand side. I kind of screwed up the order there. Okay, I would do that because you got the A, B, and C there. It makes more sense. That was a mix up. All right, so 210 degrees. What do I multiply by? It just said multiply by pi over 180. So pi over 180. So that's going to equal 210 pi divided by 180. All you really want to do is reduce the fraction. Keep it as a improper fraction. Okay, so typically when you're dealing with radians, Like it'll say pi over 4, or it'll say 3 pi over 6, or 3 pi over 8. So this one reduces to 7 pi over 6. Okay, 7 pi over 6. So 210 degrees is equivalent to 7 pi over 6 radians. Now, what is that as a degree? Well, I don't know. 7 pi divided by 6. Okay, or that's that would be the radians, 3.66 radians. Okay, 1 radian is about 57 degrees. All right, 300 degrees, what is that going to be? So take that times pi over 180 is really 300 pi divided by 180. You're really just reducing 300 divided by 180. Mackenzie, let me know what you get.
Is it, 5 pi over 3?
5 pi over 3 is correct. Okay, 5 pi over 3. 450 degrees. If you haven't done it, do 450 degrees. Like with the unit circle, you typically deal with angles from 0 to 360, but you can convert any angle, okay? Just multiply by pi over 180. Adam Libby, why don't you let me know what you get?
15 pi over 6.
Reduce that. 15 pi over 6.
5 pi over 2.
5 pi over 2. Yep, if you need to, just keep reducing. You're going to get really good with fractions, or you're really going to have, you'll get really good at fractions. Yeah, you'll get really good. All right, other direction. Let's start with pi over 6. So pi over 6 is the radian measure. That would be A there. What do we do to convert that to? Oh, yeah. All right, we multiply that by 180 over pi. The pi's cancel. You really got 180 divided by 6, 30 degrees. So pi over 6 is the same as 30 degrees. 11 pi over 12, 9 pi over 8. Go ahead and do those two. Multiply those by 180 over pi. Reduce. And then times 180 over pi. Emily, let me know what you get for the 11 pi over 12. 165 degrees. And Madison, let's see, how about for the next one? 202.5. All right, now for this one, I got a little bit of a bonus here for you because you kind of get brainwashed into thinking it has to be written in pi over 6 or pi over 12 form. Doesn't have to be. What if I said the angle was 4.5 radians? 4.5 radians, what would that be in degrees? You do the same thing, you multiply it by what? 180 over pi. It's just going to have a decimal answer. So you take 4.5 times 180 over pi. Nearest 10th. Nearest 10th. Luke, let me know what you get. Nearest 10th.
85.9.
Can't be. 85.9?
Oh, wait.
Can't be.
1 second. 257.8.
Can be. 257.8. Reason I know is because each radian is 57 degrees, or right around 57 degrees. We got at least 4 radians. What is 2 pi? So think about this, and this might be a good kind of mental picture here. Clear. 2 pi, 2 times pi is 6.28. So that's how many radians are in a full circle, 6.28. So anything less than 6.28 has to be less than 360 degrees. Anything more than 6.28 is going to be more than 360 degrees. Okay, so just a little bit of a reference there. All right, I said we come back to coterminal angles. I'm a man of my word. Find a positive angle and a negative angle that are coterminal with the following. So A is 50 degrees. Well, what does that mean? Add 360, subtract 360. So 50 plus 360 is 410 degrees. So that is going to be coterminal with 50 degrees. And then 50 minus 360 is negative 310. All right, what do we got to do with it? Now, here's one thing with angles. If you're given the problem in radians, you got to keep it in radians. Okay, if you're given the problem in degrees, you can keep it in degrees. So I got to give this answer in radians. So, but instead of adding 360, what do I add? What is the equivalent in radians to 360? 2 pi. So take pi over 6 plus 2 pi. All right, this is where you people that love fractions, this is for you. Okay, this is for you. A lot of fraction work in all these chapters. Okay. Cole, you know what that answer is, right? Without doing any work. What? You're not one of those guys that loves fractions?
No, not really.
No, not really? That's okay. Cole does.
Is it 13 pi over 6?
13 pi over 6. Now, where does that come from? You got to get a common denominator. All right, and I'm going to teach it. I'm going to go through this, but you're going to get better at it, or you're going to have to put some extra work in. Pi over 6 plus 2 pi. You want to make it a denominator 6. Think of it as 2 pi over 1. So 6 times 6 is 6. 6 times 2 pi is 12 pi. Okay? So 12 divided by 6 is 2. They got to be equivalent. So now you just add the numerators together. 13 pi over 6. Okay, the denominator you just keep 13 pi over 6. That's the first one. That's the positive one. Now we do 2 pi over 6 minus 2 pi. Well, I already know 2 pi is 12 pi over 6. So I'll make that minus 12 pi over 6. And so the negative one would be negative 11 pi over 6. So there's your two cases. Those are coterminal with pi over 6. Coterminal. All right, now for C, you do 7 pi over 4. You do the positive, you do the negative. Good practice for you, Cole. Add 2 pi, subtract 2 pi.
I do.
That's your answer? We're gonna watch your addition skills. All right, we got. Yep, very good. All right, good. Tyler, what do you got?
15 pi over 4 negative pi over 4.
Good. So you're adding 2 pi, which you're going to convert to 8 pi over 4. And so that gives you 15 pi over 4, like you said. Good. And then 7 pi over 4 minus 8 pi over 4, which would be negative pi over 4. So that's one positive. That's a positive and negative coterminal angle. Okay, 15 over 4, negative pi over 4. All right, last thing here for today. Complements and supplements, like I said, there's just a ton of stuff in this section. Two positive angles are complements if the sum is 90 degrees. Two positive angles are supplements if their measures add up to 180 degrees. Okay, just got the word positive highlighted for here in a second. Find the complement and supplement for 135. The complement would be 90 minus 35, which is 55. The supplement would be 180 minus that. What is that, 145? And for the second one, 110 degrees. 110 degrees. What's the complement for 110 degrees? There is no complement because it has to both be positive angles, okay? So you do not say negative 20. Do not say negative 20. So complement, none. Supplement, 70. All right, that's the only thing I just want to make sure that we don't make any issues with. All right, we'll get more into radians tomorrow. We'll talk about, any other
So do you mean like 17, 21?
Yep, 17, skip 19, 21. 25. I wonder if it ends on 69. Let's see here. 29, 33, 37, 41, 45. Oh, yes, it does. Actually works out for once.
Yes, there's a button, you can like, and so when people like on Earth, it just says